Okay, do you guys remember what rational numbers are? Anybody? Okay, so when I kind of plan what we need to learn this year, this is what the state of Minnesota gives me. They tell me you need to teach 7th graders this. To read, write, represent, and compare positive and negative rational numbers expressed as integers, fractions, and decimals. Have we talked about integers this year? Yeah, that's our positive and negative numbers. We've talked about fractions, we've talked about decimals. Okay, all things we've already done. We maybe just need a really good reminder of those things, okay? So, this one says, know that every rational number can be written as the ratio of 2 integers, or as a terminating or repeating decimal. Recognize that pi is not rational, but that it can be approximated by rational numbers such as 22 over 7 or 3.14. Okay, so we have to be able to do a few things. We need to be able to write a number as a fraction, recognize decimals and turn them into fractions, recognize fractions and turn them into decimals. Also be able to recognize rational numbers. So let's start with this first one. Do you guys recognize this decimal? Can you write that as a fraction? What is 0.6 repeating? This is one we kind of just need to know. Does anybody know? 0.6 repeating as a fraction? Really? 2/3? 2/3, yeah. If you didn't know that, how could we figure that out? How could I take my calculator out and figure this out? Any ideas? Okay, a good chunk of the MCA test is multiple choice. So if this multiple choice question was given to me, write 0.6 repeating as a fraction, and I was given these options, do you remember how to change a fraction into a decimal? Oh no. Are we really just tired this morning, or nobody remembers? 1/5 as a decimal. You grab your calculator. Everybody get their calculator out, because you're going to need it anyway. Okay, grab your calculator. If you need one, go borrow one. Okay, you're going to grab your calculator and you're going to do 1 divided by 5. That's 1/5 as a decimal. So 0.2. You do the top number divided by the bottom number. 5 divided by 9 is 0.5 repeating. 7 divided by 8 is 0.875. And then 2 divided by 3 is 0.6 repeating. Okay, so we could check each one. It has to be letter D because that's the only one that fits. Okay, so write 0.11111. That's 1 repeating as a fraction. Which one would that be? Is it A, B, C, or D? What do you think? And you can check them. Use your calculator. Figure out which one it is. Tyler. 1/9. 1 divided by 9 is 0.1 repeating. 1 divided by 4 is 0.25. 0.3 repeating. 1 divided by 6 is 0.16, where just the 6 repeats. Okay, so you'll have a calculator to use on the MCA test. You'll be able to do that. How about the last one? And that line, sorry, is only supposed to be over the 3. Go ahead. It would be B. Okay, this is 0.9, 0.3 repeating, 0.6 repeating, 0.83 repeating. Okay, so using your calculator to change those fractions into decimals. Okay, the second part here is circle all the rational numbers. Do we remember what a rational number is? Anybody remember the definition of a rational number? No? Okay, you're going to write this down then. A rational number is any number that can be written as a fraction, including terminating and repeating decimals. I'll give you a second to write. Any number that can be written as a fraction, including terminating and repeating decimals. Okay, and I know they're going to give you this type of question on the MCA test. They'll give you a list of numbers, and they'll ask you to pick out which ones are rational numbers, which ones are not. And it might be the type of question where you have to drag the numbers to different categories. Okay, or check all the ones that are rational. Kind of like this one, it says circle all the rational numbers. So looking at this list of numbers, can you give me at least one of them that's rational? Izzy? 4/3. How come that one's rational? Izzy, why did you choose that one? It's a fraction, right? Any number that can be written as a fraction. So that's a fraction. It's rational. Can you pick out any others then? Really? Negative 1/5. It's a fraction. Can you pick out any others? Any number that can be written as a fraction. So are there others?
-10.
-10, right? How do I write -10 as a fraction? -10 over 1. Okay, -10 over 1. So that's a fraction. Can any others be written? How about 0? Can I write 0 as a fraction? Sure, 0 over 1, 0 over 2, that's still 0. So 0 is a rational number. Okay, then if you see the square roots, if they work out to be a nice number, they're rational. Okay, so the square root of 6, can we do that in our calculator? Do you remember how to do that? The square root of 6, second, the x squared button, 6. This ends up being 2.449489743. Is that a nice number? No. Do you remember how to get that on your calculator? No? You have to hit the second button. And then the x squared button. And then type in 6. And hit equals. Try that. Make sure you know how to use your calculator. Some of you just have a square root button that you can. So yours is. You're going to take the 6 and then you're going to shift this button. Okay. So you're going to hit second, that button, and then 6. Then you're going to change it to, remember around where it says 1 and then 7. Don't go down here to classic. It's in that right here. Classic. Now. Okay, everybody know how to do that? No. Hit second, the x squared button. Now type in 6 and hit equals. Okay. So square root of 8, does that turn out to be a nice number?
No.
No, the square root of 8's not. How about the square root of 9?
Yes.
Yeah, the square root of 9 is just 3. Can I write 3 as a fraction?
Yes.
Absolutely, so that is a rational number. Okay, so if they're a big long decimal, it's not rational. If it just is a very nice number, then it's rational. Questions on that piece? Okay, you're going to see some questions like this. Understand that division of two integers will always result in a rational number. If I can take two numbers and divide them, it's rational. And then use this information to interpret the decimal result using a calculator. So writing this as a decimal, you can use your calculator. What's negative 29/40th as a decimal? Use your calculator. How do you get that? Remembering that this fraction bar needs to divide. So you're just dividing, you're doing 20. Don't even worry about the negative sign. Just do 29 divided by 40. Put a negative sign on your answer. What do you get? Yeah. Negative 0.725. There's your answer. Is that a rational number? Is negative 0.725 a rational number? Some of you are shaking your head no, but let's go back to the definition. The definition of a rational number, any number that can be written as a fraction, including terminating or repeating decimals. This is a terminating decimal. It started as a fraction, right? It was a fraction, so it's a rational number. Okay? The next one, write the number as a mixed number. Okay, writing this as a fraction. Negative 1.7. Remember how to do that? So you have a whole number, negative 1, and then you have a fraction. What's the fraction going to be? If you were to read that in mathematical form, it'd be 1 and what? Caleb. 7 what though? Brinley.
7 over 100.
Not over 100. Hannah? Not over 1. 10, right? This is the 10th place. So it's 1 and 7 tenths. So negative 1 and 7 tenths. Can I simplify that at all? Okay, so let's try another one. What if I gave you this? 3.06. How would I write that? Brinley.
3, 6 over 100.
This would be 3 and 6 100ths. Because the 6 is in the hundredths place. Can I simplify that? You should always simplify it, which I can. I can divide these both by 2. So it'd be 3 and 3/50ths. Okay? Remembering? Is this coming back to us a little bit? Is it a good thing we're reviewing these things?
Yeah.
Okay, good, because I'm getting a little worried, you guys. Is it, yeah? Better than maybe? Okay, let's look at this. Another one of the standards that are listed by the state of Minnesota are to locate positive and negative rational numbers on a number line. Understand the concept of opposites and plot pairs of positive and negative rational numbers on a coordinate grid. So opposites. Okay? If I give you the number 5, what's the opposite of 5? Negative 5, right? The opposite is just the negative or positive. So the opposite of 5 is negative 5. What's the opposite of negative 8? 8, okay? The opposite of 3/4. No. The opposite of positive is a negative. The opposite of a negative is positive. So we're just making it negative if it's positive. So negative 3/4. What's the opposite of negative 8.7? Positive 8.7. The opposite of negative 5/6? 5/6. The opposite of 20.1? The opposite of 1? Okay? Okay, then the next part is find the value of the variable. Okay, so here we have a number line. Right here is 7.6. It's kind of hard to read. Over here is 7.7. I want to know what this would be right here. Any ideas? It has to be somewhere between 7.6 and 7.7. So some of you might be thinking, but there's no number between there. Yeah, there is, right? There's a number between any number. It just has more decimal places. So one way to look at this, you guys, is I could take this first number and write it as 7.60. Right? Is that okay to do that? Yeah, you can put a 0 at the end. And this would be 7.70. So that might help you then see what the value of S would have to be. What do you think, Izzy?
7.69.
Yeah. So this would be 7.61, 7.62, and so on. S would be 7.69. Okay. How about in the next number line, V? Here we have 7, and here we have 8. So what would V be? Brooklyn, what do you think?
7.1.
7.1. Right? 7.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then we'd be at 8. So V has to be 7.1. Okay, questions there? All right, flip the page. All right, these numbers are kind of small, but I think they're readable on your paper anyways. Maybe kind of hard to see on the board. Okay. One of the other things we have to do is compare numbers. Be able to list them from least to greatest. Be able to tell which one's bigger, which one's smaller. So putting these numbers from least to greatest, okay, these are the numbers we have. We have 7 and 18/36, -7 and 21/35, and -7.4. Those are our three numbers. If I'm looking at these three numbers, can you automatically pick out which one's the biggest?
Let's switch.
Oops, sorry. Uh-oh. It, like, disappeared. Can you automatically pick out which one's the biggest? You should be able to. Look at these three numbers. Can you pick out which one's the largest of the three? And why? It's really kind of common sense. Tyler?
It's not negative.
Yeah, right? These two are negative. This one's positive. So this one has to be the greatest. Everybody agree with that? So I'm going to look at my options here. Can I eliminate a couple of the choices?
Yes.
Absolutely. I can eliminate the first one, and I can eliminate the third one. Because we're going from least to greatest, the 7 and 18/36 has to be at the end. Okay, then we need to pick out between these two numbers, which one's the smallest. And I think it's helpful to write them as decimals. It's going to be much easier as a decimal. So I'm going to do 21 divided by 35. So this is -7.6. Which is smaller, -7.6 or -7.4? Really?
-7.4.
Careful. When they're negative, the one that's more negative is actually smaller. So this right here is the least number. So then I look at my options. If that's the least and that's the greatest, is it the second one or the last one? The last one, right? Because the least is -7 and 21/35. and then negative 7.4, and then 7 and 1836. But you guys, part of the MCA test is really going to be able to narrow down which ones it can't be. If you can get rid of 2 of the answers, now you got a 50-50 chance, even if you had to guess. Right? You just increased your chances of getting it right. Okay, the last one here. This time we want to go from least to greatest again. Can you pick out which number is the greatest? Our numbers are negative 11 25ths, 7 and 2 40ths, and then negative 30 over 40. Which one's the greatest? Go ahead. Right, this is the greatest. So I'm going to put 7 and 2 40ths at the end. Okay, then use your calculator and let's write the others as decimals. What's negative 11 25ths as a decimal? So you use your calculator and do 11 divided by 25.
0.44.
So it would be negative 0.44. And then if we do 30 divided by 40, you get negative 0.75. Which is smaller? Which one is more negative? Go ahead, Kev. Yeah. So this is the least. So in order from least to greatest, we'd have to put negative 30 over. Why does this keep happening? Negative 30 over 40, and then negative 11 25ths. Questions there? Okay. Then a couple other things just to remember. Using positive and negative numbers with exponents. And hopefully we remember what an exponent is. So if I ask you to write this expression using exponents, okay, I'm not asking you to evaluate it, I'm asking you to write it with an exponent, so it would be 9 to what power? Izzy? 4. 9 to the 4th power. Doesn't look like 4. Okay. If it says evaluate, then we want an answer. Okay, so when I ask you to evaluate 1/2 to the 3rd power, that means 1/2 times 1/2 times 1/2. You guys fractions, you guys multiplying fractions? Multiply the top numbers, multiply the bottom numbers. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So you have 1/8. If it's decimals, use your calculator. 0.03 squared. That means I need to do 0.03 times 0.03. And you get 0.0009. Okay, what would 3/4 to the 2nd power be? That means we have to do 3/4 times 3/4. Multiply the top numbers, multiply the bottom numbers. What do you get? Savannah.
9/16.
9/16. Okay, 4 to the 3rd power. 4 times 4 times 4. Go ahead, Brendan. 64. Okay, sometimes it's going to be written like this. 2 to the 4th power. Just write down the words. But what that really means is 2 with an exponent of 4. My board is going crazy. So 2 times 2 times 2 times 2. Izzy. 16. And then the last one, 5 to the third power. 5 times 5 times 5, really. 125. Questions there? Okay. Then we have to remember this. Do you remember what these lines mean? Anybody remember what those two vertical lines mean around a number? If you read above it, then you might.
Absolute value.
Absolute value. It says, demonstrate an understanding of the relationship between the absolute value of a number and the distance on a number line. Okay? So, these symbols, those vertical lines, mean absolute value. Anybody remember what absolute value means? If you need to write this down somewhere. Absolute value is the distance a number is from 0. It's always positive. Okay, absolute value is always, always, always positive. Because I can never travel a negative distance. Even if I walk backwards, I'm still traveling a positive amount. So if I said, what's the absolute value of negative 3/5? You would say what? How far is negative 3/5 from 0? 3, what? It's a fraction. So 3/5. Okay? Absolute value is always positive. So the absolute value of negative 3/5 is positive 3/5. Okay? What's the absolute value of negative 0.93? Don't make it hard. It's just what? 0.93. What's the absolute value of 2.6? 2.6. Okay, that's it. Now, sometimes you're going to be asked to do some math first. So, what is the absolute value of 7.3 minus 9? We have to do 7.3 minus 9 first. We can use our calculator to do that. 7.3 minus 9 is negative 1.7. Now, I want to know the absolute value of negative 1.7. Izzy? 1.7. Because absolute value is always positive. And what is the absolute value of 3 3/5 plus 2 1/6? We have to add them together first. How do we add fractions? Do you remember? Caleb?
Add the whole numbers.
Okay, add the whole numbers first. 3 plus 2 is 5. Then we have to add the fractions. 3/5 plus 1/6. Do you remember how to do that? Can't just add them. Remember, you have to get a common denominator. Or do the butterfly method. Remember the butterfly method? So 30, 6 times 3 is 18, 5 times 1 is 5, so we can add 18 plus 5 is 23 over 30. So our answer is 5 and 23/30. What's the absolute value of 5 and 23/30? That answer, right? It's the same thing. So the absolute value of that is 5 and 23/30. I know this is a lot to remember. Okay. Okay, the last one. If 2 equals the absolute value of x, which graph do you think represents x? What could x be? If the absolute value of x is 2, what might x be? Go ahead.
Negative.
It could be negative 2. Could it be positive 2?
Yeah.
Would you agree with that? So x could really be 2 or negative 2. So which graph shows that x could be 2 or negative 2? Brinley. B. Okay. It can't be A because A only shows 2. C only shows negative 2. And D is showing 2 and negative 2, but everything else in between. And it can't be everything in between. Okay, it can only be 2 or negative 2, so that's why it has to be B. Okay, I know that was a lot, right?